So what did you guys get for the 4 to the power of negative 2? Yeah, which is 1 over 16. 5 to the power of negative 2? Is 1 over 5 to the power of 2, which is 1 over 25. Have you noticed any pattern so far between this one and the one before, the column before it? It's 1 over that answer, right? So it's the inverse of that answer. Okay, so for 6 to the power of negative 2 is 1 over 6 squared, which is 1 over 36. And for 7 to the power of negative 2 is 1 over 7 squared, which is 1 over 49. Are you guys okay with that? All right. Now we're going to look at what happens when I have to the power of a half. Okay? So here's what I want you to do. Take your calculators out, and then we are going to look at 1 to the power of anything is going to be 1. Okay, so I want you on the calculator to put this 4, and then your power button, whatever your power button is, open bracket, 1 divided by 2 close bracket. Make sure that your exponent is in brackets, okay, or you enter it as 0.5. So 4. Put your power button, which is either the x, y, y, x, or the hat, yeah, and then put bracket, bracket, bracket. No, you're good. This is the button, yeah. So put bracket, 1 divided by 2. And what do you guys do? What did you guys get? 2. Okay. Now do the same thing for 9 to the power of half. What are you going to get? 3. And then for 16 to the power of half. 4. 25 to the power of half is 5. 36 to the power of half is 6. 49 to the power of half is 7. Now here's the question for you guys. What do you notice between this and this? Talk about the base, talk about your answer. It is. Yes? So basically what's happening here, if I look at 9 to the power of half is equal to 3, but if at the same time, if I do the square root of 9, what is it going to give me? 3. What if I do the square root of 16? What am I going to get? What if I do the square root of 25? 5. So that power of half is the same thing as the square root. So I can write it as power of a half, or I can write it as a square root. They mean the same thing. Okay? And you see that your answer here is your base in the first one, yes? And then your base here is your answer for the first one. Okay? Now if I do this one here, what's 3 cubed? 27? And then 4 cubed is, I'm guessing it's 64. 5 cubed is 125. 6 cubed is, and 7 cubed, 343. Yeah. Now, without using a calculator, can you tell me what would be the answer for 3 to the power of negative 3? 1 over 27. That's right. So if you look at this, 3 to the power of negative 3 is 1 over 3 cubed, which is 1 over 27. And then if I have 4 to the power of negative 3, that's 1 over 4 cubed, which is 1 over 64. So we can guess the answer for the rest. So for this one, what you're going to enter on the calculator, you're going to enter 27 to the power of 1 over 3. And that's going to give you 3. And if you do 64 to the power of 1 over 3, that's going to give you 4. 5, 6, 7. Now here is my question to you guys. We can kind of tell that the exponent of 3 and the exponent of 1/3, they're opposite of each other. Yes? Right? Because I'm doing the opposite, the inverse. Now here's my question to you. If you have x cubed and you want to get rid of the cube, what do? What is it? It's cube root, right? To get rid of that cube, you're going to have to cube root, okay? In this case, instead of cube rooting, so if I want to get rid of that cube, I'm actually doing to the power of 1/3. That being said, cube root and the power of 1/3, they do the same thing. They mean the same thing. Like we did with x squared, with the square root of x squared, and with x squared to the power of half. These mean the same thing. They're equal to each other. Okay? So what happens is, anything, so if I have, let's say, x to the power of 4 and I want to get rid of the 4, I do the 4th root, right? To get rid of that 4. It's the same thing if I actually do to the power of 1 over 4. So that 4th root and that 1 over 4, they mean the same thing. Yes? If you have anything, let's say if you have the power of 1/5, 1 over 5, how can you write that in radical? 1 over 5. How can you write it as a root? What root would it be? So if you have x and then power of 1 over 5, if I want to write it as a root, what would it be? 5, the 5th root. Okay? You see that? So that bottom denominator, that one here, goes inside your root. Okay? The case with a square, we don't put it in because that's the only root that we, like, that's the standard root. Okay? We don't put a 2 there, but we say it's a square root. Okay? So let's see why that's the case. Why is, so if I have x squared, right, and I want to get rid of the squared, we know that I square root, and we know that the square root cancels the square. You guys agree with that? And that becomes x. You guys agree with that? Now let's look at the same idea, but with a power of a half. So if I have x squared and then a power of a half. You learned yesterday with the exponent law, when I have a power to the power, what do I do with them? I multiply them. So that's going to be 2 times a half. What's 2 times a half? You have 2 halves, that makes a 1, right? So that's the same thing as writing x to the power of 1, which is x. You see why they're the same? I'm going to give you another example here. What do you do to get rid of that power of 4? It's not called square. What is it called? Fourth rooted, right? Because you have to use the same power in the root. Okay? So that gets rid of the power of 4, so that gives you an x. Yes? Okay. Now, what if I raise it to the power of 1/4? What do I get? Exponent law says when I have power to the power, I multiply the power. If you haven't learned yesterday's lesson, you're going to be using it. Okay? Whenever I have power to the power, I multiply my exponent. So that's going to be 4 times 1/4. What is 4 times 1/4? 4 times a quarter is 1. Right? Because what happens is that becomes 4. 4 times 1 is 4. 1 times 4 is 4. So 4 over 4, that equals to 1. So you see my answer is the same if I do a 4th root or if I do a power of a 1/4. They mean the same thing. Are you guys okay with that? It doesn't matter which one you do. Okay? But sometimes the question is going to ask you to go between from this form to this form or from the other way. You have to know both. All right. So we have learned that. I've already discussed all of this with you guys. So we have learned, I will post the answers. So we have learned that 1 to the power of 1 over n is the same thing as the root of a to the power of the nth root. Sorry, yeah. So it's the nth root of a. So let's say if I have a to the power of 1 over 6, how would I write that as a root? Sixth root of a. Is that clear for everyone? Good. So I'll leave filling out these tables for you guys to the end of this lesson. So here's what happened when I have a to the power of m over n. So this here is the same as writing the nth root because that n is in the denominator. Okay? So we've done that part. But what's missing is that now in this case, it's going to be a to the power of m. So that power of m sticks with the a. Okay? There's two different ways that we can write this. We can write it as the nth root of a to the power of m altogether, or we can write it as the nth root of a to the power of m, and they both give you exactly the same answer. Let's look at some examples here. So if I have a to the power of 3 over 2, we call this form the rational form. Okay? It's called rational because your exponent is a fraction, and a fraction is called rational. Okay? So how can I write this in a radical form? So this is called the radical form. So I put my root. What do I put in the root right here? 2, right? Now, I don't have to write the 2 because 2 is the actual, like this is the what do we call it? The standard form, right? The default, that's what I meant. And then a to the power of 3. Okay? So this is called radical form. Okay? Okay. What form is this in? Radical. Can you write it in rational form, please? Power of 5 over 4. Make sure that the 5 over 4 looks like it's a power, okay? Let's look at something a little bit, let's look at why this is, okay? I just want to show you why this is. I'm going to look at the math behind it, okay? So if I have this, sorry, that is supposed to be 1 over 4. If you want to simplify this, how would you write this? What do you have here? Exponent to the exponent. So what do I do with my exponents? Multiply them. So that's going to be a 5 times 1 over 4. 5 times 1 over 4. Again, for those of you who don't know how to multiply fractions, you do 5 times 1, so the top by the top, the bottom by the bottom. Okay? So that becomes a 5 over 4. Yes? Okay. Now, let's look at if I have a to the power of 5 to the power of 1/4. How can I write the 1/4 as a radical? What would it be? So as a radical, what do I put here? 4, because that's your denominator, yeah? And then what goes in here? A to the power of 5. Now look back at the previous question when I gave you this. Yeah? What did you say is equal to? 5 over 4, yes? You see how if I go either by using my power to the power or by writing it as a radical format, I'm getting the same answer as if I go from here to here. Okay? So there is a reason why that is. You see what I mean, guys? You understand what I'm trying to tell you? So you see this answer here is the same as this answer, and this answer here is the same as this answer. And they all go because I have either used my power to the power law or I've used my radical format.